Okay, so I'm hoping you guys took that opportunity to set this one up. So the probability of success is 1 out of 6, so it's going to be 1 out of 6 cubed, and 5 out of 6 to the first power. Okay, following my formula. Probability of success, okay, probability of failure. And if I did that out, this should be 4 times 1 over 6 times 6 times 6, 216 times 5/6. I don't know if I have that separate. Let me see if I did that separately, or if it's all in one answer. I think I did. That's 0.015, okay? So that's 0.015 right here, 0.015. Now let's do the probability that x equals 4. So that's 4 over 4, and it's 1 over 6 to the 4th, 5 over 6 to the 4 minus 4, which is 0. This is just 1. This is 1, okay? And then you have 1 over 6 to the 4th. That's 1 over, I got 0.001. So I take 0.005, 0.001, and I get 0.016. So not very likely, between 1 and 2%, about 1.5% times. There's a 1.6% chance of getting doubles 3 or 4 times when you roll it 4 times. All right? All right, here we go. Says Ashley makes 80% of her free throws. In a game, she takes 3 free throws. Decide whether the experiment is a binomial distribution. If it is, specify the values of n, p, q, and list the possible values of random variable x. Okay. Let's take a look. So let's see, we got to do bins for this, right? B-I-N-S, binomial. Okay, that's success or failure. So it says that she makes 80%, so it's made or make, and miss. Independent, the shots should be independent of each other. Number, yep. N equals 3, probability of success, 80%, all from the same spot, free throws. So it is a binomial distribution. N, P, Q. N is 3, it's your number of trials. P is your probability of success, and that's going to be 0.8. Q is the probability of a failure, and that is 0.2. Okay, and then they want to list the possible values of x. Well, that means that the probability that x equals 0, the probability that x equals 1, the probability that x equals 2, and the probability that x equals 3. Those are the only things that can happen. If you shoot it 3 times, you make none of them, you make 1, you make 2, you make all 3. Okay? So if you make 0 shots, I'm going to show you how to do it with the formula. Okay, that means you're taking 3, making 0. Probability of success is 0.8 to the 0 power. Okay, and the probability of failure is 0.2 cubed. So there's that probability. 1 make, 2 makes, and all 3 makes. Okay, so there are your possibilities. Now, there's a faster way to do that, isn't there? The probability that you make, you could do it like make and miss. So you figure out 0.8 times 0.8 times 0.8 for 3 makes, and so on. So let's figure this out. So this is 1, this is 1, 0.2 to the third is 0.2 times 0.2 times 0.2. So when we do that, we should get 0.08, I believe. 0.008. This one, 3 over 1 is 3 times 0.8 times 0.04. So 3 times 0.8 times 0.04, 0.096. Okay. The next one, this is also 3 times 0.64 times 0.2. 3 times 0.64 times 0.2, 0.384. And then we have 0.8 to the third, and that's 0.512. Okay? So the probability that she makes all 3, the probability that she makes 2 out of 3, the probability that she makes 1, the probability that she makes 0. Okay? All right, moving along. Moving along, here we go. And here is where I'm going to show you the shortcut, okay? Let's do this one here. So it says the probability that Jenna makes a three-pointer is 35%. Find the probability that Jenna will make 20 out of her next 50 shots. So I want you to set that up first. Okay, set it up. Set it up in that big long formula. And then I'll show you the shortcut. Okay, so hopefully you set it up this way. Well, there's 50 shots, right? And you want to know the probability that she makes 20 of them. The probability of success is 0.35, so that's 0.35 to the 20th. The probability that she misses is 0.65, and that would be to the 30th. Okay, so that is how we set that little puppy up. And we're going to find that probability. Okay, we're going to find that probability, and that probability is going to be 0.0875. Okay, so here's how you do it in the calculator. Here's how you do it in the calculator. Write these steps down. Okay, these steps are going to make this process a whole lot easier. All right, so what are we talking about? We're talking about a binomial distribution. We're talking about a binomial probability distribution, okay? A binomial probability distribution, okay? Binomial probability distribution. So, we are going to look where our distributions are. On our calculator, our distributions are right here, okay, where it says dister, okay? So I'm going to hit second dister, and I have to scroll down to get to the binomial ones, okay? There it is. Now, I don't want the bottom one, I want this. We're going to do binomial PDF, okay? I'll explain why in a little bit. Binom PDF. You're looking for 1. When you're looking for 1, it's PDF. Okay? If you're looking for something that's less than or equal to something, that's more than 1. Okay? Less than or equal to a number, which means more than 1. Then you want binom CDF, and I'm going to show you that in a minute. But for right now, we're concentrating here. Binomial PDF, okay? So you go to that binomial PDF, you hit enter. Trials, how many trials do I have? Well, I have 50 trials. The probability of success is 0.35. My X value is 20. And there it is, okay? A lot faster than going through that formula. But the formula is important to knowing what you're doing. So that's why we do it, okay? There it is. We'll have more practice on that shortly, okay? But I do want to show, well, let's do this. What's the probability that she makes 15 of her next shots? The probability that X equals 15. Okay, random variable X. So I want you guys to try that. Try it. Same data, okay? P still is 0.8, your probability of success. Your N is 50, and X is 50. Try it. Try typing it in. Let's see if you can do that successfully. So I hit second, I hit dister, I go down to binom PDF, I hit enter, there's 50 trials, I want to see 15, and that tells me my answer is 0.092. 0.092. Okay? Does that make sense? So what I want you to picture, okay, and it's going to help us with our next idea, I want you to picture this binomial distribution, this binomial probability distribution, okay? There's 50 shots. So here's 1, here's 10, here's 20, 30, 40, all the way to 50. There's 50 shots. So if you wanted to find the probability they make 20, you're looking for just this moment in time. You're looking for that one probability, and that's what we did. 50 choose 20, okay? And then we had 0.35 to the 20th power, and we have 0.65 to the 30th power, okay? That's a binom PDF. And the reason it's a PDF is because you're looking at one thing in time. That's it, just that one thing. Okay? So, my next question will be, find the probability that she makes at least 20. Out of her next 50. Okay? What is the probability that she makes? Actually, I'm going to change that. I want to do that next. Okay? Probability she makes, let's do this first. Find the probability that she makes no more than 50. So now we got to start taking the language and interpreting that into the stuff that we're looking for. Okay? Trying to take that and interpret. Take and interpret. So, no more than 50. What does that mean? How do I write that? Probability of what? How do I write that? Think of how I write that with like inequalities. Is that X is greater than 20? Is it X is less than or equal to 20? Is it X is greater than or equal to 20? That's what we have to think about. That's what you guys have to get straight. Okay? No more than 20. Oh, that says no more than 50. Sorry. I was thinking. No more than 20. No more than 20. That means, let's quiz ourselves. No more than 20. Is 10 no more than 20? Yes. Is 15 no more than 20? Yes. Is 20 no more than 20? Yeah, it's 20. So no more than 20, we're talking the probability that x is less than or equal to 20. Okay? So, all of these probabilities have to add up to 1. Okay? All of these probabilities, when she makes 1, she makes 2, she makes 3, she makes all the way to 50. All of those probabilities add to 1. Okay? We want to find x is less than or equal to 20. We want to find here. Okay? So we are going to use the binom CDF. Binom CDF finds x is less than or equal to some number. Okay? That's what binom CDF is created for. Okay? It's not created for x is greater than or equal to 20. It's only less than or equal to 20. So what it does is, it takes all these probabilities, 51, 52, 50 choose 3, 50 choose 4, 50 choose 5. It takes all of those little probabilities that you could find each one doing binom PDF. It takes all of them and adds them together for you, which is a great power of the calculator. The great power of the calculator. But remember, binom CDF is for x is less than or equal to. That's what it's for. That's what it's designed for. Okay? So we have to go to our calculator and we have to type this in. So I go over to my calculator and I hit second vars for dister. I go down to binom PDF and I find binom CDF. There are 50 trials. My probability of success was what, 0.35? We're still doing the 3-point shots, right? Yeah. And the x value is 20. I hit enter, and I get 0.8139. Okay? So, binom CDF. My number of trials was 50, my probability is 0.35, my x was 20. It's a CDF, 0.81, I forgot what I said, 0.8139. Okay? I'm hoping that makes sense. Okay, I'm hoping that makes sense. So, let's go back to that other example that I had up there. Find the probability that she makes at least 20 shots out of her next 50. Okay? So we erase this stuff, and let's think about what that means. What does at least 20 mean? What does at least 20 mean? Well, to me, it means the probability that x is at least means greater than or equal to 20. So it's like taking these probabilities and adding all of these probabilities together. However, there's no button for that. What does binom CDF do for us? Binom CDF adds for less than or equal to. Binom CDF is for less than or equal to. So I can't just take it and make it greater than or equal to, it's not going to come out right. So the key is, how can I take this? How can I take the probability that x is greater than or equal to 20 and write that as something that's going to be less than or equal to? Okay, because that's what I need. So, if you remember, I told you that all of these probabilities have to add up to be 1. Okay? So if all of those probabilities add up to be 1, and I want to find this, then I could